Welcome to the third lab of Introductory Physics. In this lab we will speak about black holes and how you can discover the presence of a black hole. So what is a black hole? A black hole is a region in space where the gravitation force is so strong that even light cannot escape. It is very difficult to detect a black hole because black holes do not reflect or emit optical waves. Furthermore, black holes are very small in comparison to the large objects in space. A possible way to predict the position and the mass of a black hole is using Newton's law of universal gravitation. Newton's law of universal gravitation defines the net force equal to the gravitational constant g times the masses m1, which is the mass of the star, and m2, which is the mass of the black hole, divided by the square of the distance between the star and the black hole. If we can calculate the net force with the change in momentum over time, we can calculate the mass of the black hole with this equation. Let's look at our program. The mass of the star was changed to our value 2.269 times 10 to the power of 27 kilograms, and the change in time was 86,400 seconds, which is a day in seconds. I place two counters in my program to get the average mass of the black hole. Furthermore, the positions of the black hole are written here. So we can write the equation for the final and initial velocities as well as the final and initial momentum. With them we can calculate dv and dp as well as Fnet. The distance between the star and the black hole is given here, and there will be a trail between the black hole and the star. Finally, we can write the equation for calculating the mass of the black hole. It is shown here. At the end, we can calculate the average of the mass of the black hole, as shown here. So we can run the program and see if that works. You see here the star moving, here's the black hole, this is Fnet, this is F perpendicular, and this is F parallel. It is shown that the program works very well. At the end, we get an average mass of 1.98895 times 10 to the power of 31 kilograms. The mass of the black hole is much larger than the mass of the star. So let's answer the questions. The first question is, what is the difference between Fnet and dp over dt? We set them in the program equal, and that is true, but only if dt is very small. In our case, dt was large, and therefore Fnet is only roughly dp over dt. This also counts for the parallel and perpendicular case. The other question is, what if you replace the black hole by a different black hole? If the mass of the black hole is larger, the path of the star will be smaller because the gravitational force is larger. On the other hand, if we decrease the mass of the black hole, the path will become larger. However, in the question it is stated that the motion of the star will be unchanged, and that means that the new black hole has the same or a very similar mass as the other one. Therefore, we cannot detect that the black hole was replaced by another black hole. Thank you for watching this video.